Hello, my dear students. This is Suja, your chemistry teacher. I hope you all are doing good. So, we have been seeing the five basic laws of chemical combination and we are discussing them one by one. So, this is the third law that we are discussing, and this is law of multiple proportion. If you have not watched my videos on the first two laws, I suggest that you have a look at it, and the link for those two videos are given in the description box below. So without wasting much time, let's get into the law of multiple proportion explained for you.
We are going to see the law of multiple proportion in detail today. Do you know who proposed this law? This law was proposed by John Dalton. So how was this law defined? The law of multiple proportions states that if two elements form more than one compound between them, then the ratio of masses of the second element which combine with the fixed mass of the first element will always be ratios of small whole numbers. The law seems to be a bit confusing and very long. Let's look at it with a few examples, and I bet it's not as difficult as it sounds. The first example I'm taking to explain the law of constant proportion is the formation of oxides of carbon. We know that carbon can combine with oxygen to form either the dioxide, which is carbon dioxide, or the monooxide, which is carbon monoxide. What is the molar mass of carbon? The molar mass of carbon is 12 grams. And what about oxygen? The molar mass of oxygen is 32 grams. So in carbon dioxide, 12 grams of carbon combines with 1 mole of oxygen, or it is 32 grams of oxygen. So 12 grams of carbon combines with 32 grams of oxygen. Whereas if I take carbon monoxide, 12 grams of carbon is actually combining with only half mole of oxygen, or it is 16 grams of oxygen. So 12 grams of carbon is combining with 16 grams of oxygen to form carbon monoxide. So now if I try to find the ratio of the mass of oxygen for fixed mass of carbon. So what did I say? In carbon dioxide we have 12 grams of carbon combining with 32 grams of oxygen, or for every 12 grams of carbon we have 32 grams of oxygen in carbon dioxide. And what about carbon monoxide? 12 grams of carbon combines with 16 grams of oxygen to give carbon monoxide. So the fixed mass of carbon, if I take it to be 12 grams. So for every 12 grams of carbon, what do I have? I have 32 grams of oxygen in carbon dioxide and 16 grams of oxygen in carbon monoxide. So it is the mass of oxygen in carbon dioxide to the mass of oxygen in carbon monoxide is 32 to 16. This will work out to be 2 to 1. So the ratio of the second element, that is oxygen, combining with a fixed mass of the first element. What is the first element? Carbon, which is 12 grams. That ratio is in simple whole numbers, which is 2 to 1 in the case of the oxides of carbon. This is the law of multiple proportion. So the next example I'm taking to explain the law of multiple proportion is that of methane and ethane, the alkane series of the hydrocarbons. Now in methane, we know that one atom of carbon combines with how many atoms of hydrogen? 4 atoms of hydrogen. So the molecular formula of methane is CH4. Whereas in ethane, I have 2 atoms of carbon combining with 6 atoms of hydrogen. So the molecular formula is C2H6. So if I take a mole of methane, in 1 mole of methane, I will have 12 grams of carbon and 4 grams of hydrogen. How? Because 1 mole of carbon weighs 12 grams. and 1 mole of hydrogen weighs how many grams? 1 gram. So I have 1 mole of carbon in methane, so 12 grams, and 4 moles of hydrogen in methane, so it is 4 grams of hydrogen. What about ethane? Because the molecular formula of ethane is C2H6. In a mole of ethane, I have 2 moles of carbon. So it is 2 into 12, which is 24 grams of carbon. And 6 into 1, which is 6 grams of hydrogen. So for every 24 grams of carbon in ethane, we will have 6 grams of hydrogen. To explain the law of multiple proportion, we need fixed mass of one element. So let us take that fixed mass to be that of carbon, and that to 12 grams. So in methane, we know that for 12 grams of carbon, we have 4 grams of hydrogen. What about ethane? In ethane, 24 grams of carbon combines with how many grams of hydrogen? 6 grams of hydrogen. So I need a fixed mass of carbon, that is 12 grams of carbon. So how many grams of hydrogen will be there in 12 grams of carbon? It will be 12 multiplied by 6 upon 24. This will work out to be 3 grams. So I have 3 grams of hydrogen for 12 grams of carbon. So the fixed mass of carbon is 12. So in methane, for 12 grams of carbon, I have 4 grams of hydrogen, and in ethane, for 12 grams of carbon, I have 3 grams of hydrogen. So what will be the ratio of hydrogen in these two compounds? So for 12 grams of carbon, the ratio of mass of hydrogen in methane to ethane will be 4 to 3. This is in ratio of simple whole numbers. So for fixed mass of carbon, what is the fixed mass of carbon? For 12 grams of carbon, the ratio of mass of hydrogen is in simple whole numbers, which is 4 to 3 in case of methane and ethane. Let's proceed with the next example. The third and the final example I'm taking is the oxides of nitrogen. Nitrogen forms a variety of oxides, and let me try to explain the law of multiple proportion in this example, that is the oxides of nitrogen. So nitrogen combines with oxygen to form NO, NO2, NO, N2O, N2O3, N2O4 and N2O5. So the blue spheres here represent nitrogen and the red sphere here represents oxygen. So we have total of 6 oxides of nitrogen. So let's take a quick look as how this law of multiple proportion holds good in the oxides of nitrogen. In this table, I have given the mass of nitrogen and mass of oxygen in 1 mole of the various oxides of nitrogen. Now you must remember that nitrogen exists as a diatomic molecule N2 with a molar mass 28 grams. Oxygen exists as a diatomic molecule again, and the molar mass is 32 grams. If I take the atoms, nitrogen as such, 1 mole of nitrogen atom, then it will weigh 14 grams, and 1 mole of oxygen atom will weigh 32 upon 2, which is 16 grams. So in NO, I have 1 atom each of nitrogen and oxygen. So the mass of nitrogen is 14 and the mass of oxygen is 16 grams. So for every 14 grams of nitrogen, how many grams of oxygen do we have? We have 16 grams of oxygen in NO. In N2O, because I have 2 atoms of nitrogen, the mass of nitrogen is 28 and 1 atom of oxygen is present, so the mass of oxygen is 16. So I'm taking here the mass of nitrogen to be fixed. So I have to find the amount of oxygen or the mass of oxygen that is present in 14 grams of nitrogen in each of these compounds. So In N2O, I have 28 grams of nitrogen for 16 grams of oxygen. I need how many grams of nitrogen? 14 grams of nitrogen. So what will be the mass of oxygen? It will be 14 upon 28 multiplied by 16, which will work out to be 8. Similarly, you can do the calculations for the other oxides NO2, N2O3, N2O4 and N2O5. So for 14 grams of nitrogen, the mass of oxygen in all these compounds works out to be 16, 8, 32, 24, 32 and 40. So if I try to find the mass ratio of oxygen in each of these compounds, then it is 16 to 8 to 32 to 24 to 32 to 40. So divide everything by 8. So it is 2 to 1 to 4 to 3 to 4 to 5, which is again in ratio of simple whole numbers. So if I take fixed mass of one element and try to find the ratio of the mass of the other element, then that will be in simple whole numbers if I have two elements combining to form a variety of compounds. This explains the law of multiple proportion.
So that's it, my dear students. I hope you understood what the law of multiple proportion is. If you found this video useful, please don't forget to hit the like button and also share it with your friends. Also consider subscribing to my channel. So until I see you with the next law of chemical combination and another interesting series, this is Suja, your chemistry teacher, signing off. Take care and bye-bye.